Learn oilfield stuff. Hey there! Welcome back to Learn Oilfield Stuff, the ultimate channel for all things related to the oil and gas industry. Our expert team is dedicated to bringing you informative articles in a fun and engaging way. So, if you're ready to take your knowledge of the oil field to the next level, hit that like button, share this video with your friends, and don't forget to subscribe to our channel. Today, we're going to talk about drilling fluids. I know, it sounds like it's going to be a dry subject, but I promise it's going to be interesting. We're going to dive into the nitty-gritty of the Daily Drilling Fluid Report, or as it's commonly called, the MUD Report. Now, the MUD Report is one of the most important reports at the well site. It contains a lot of crucial information about the drilling process. It contains basic well and rig information, chemical inventory, mud system costs, and a list of the fluid properties of the mud system. And you know what, that's not even the best part. The MUD report will also give us an insight into the tests conducted on the drilling fluid to maintain the required properties. The first test we're going to talk about is the density of the drilling fluid, measured in pounds per gallon. The density of the drilling fluid is important to maintain well control, and to do that, some weight material must be added to the fluid. The most common weight materials added to the fluid are barite and hematite. The mud's density is measured using a mud balance. This balance contains a mud cup on one end of a beam with a fixed counterweight on the other end of the beam. When the cup is filled with fresh water, steel shot is added to the counterweight container until the beam is level, with the rider pointing at the 8.34 scribe line. During well site operations, the mud's density is checked by filling the cup with drilling fluid and moving the rider until the level bubble indicates the beam is balanced. The density is then read using the position of the rider. Pretty cool, right? The next test is the plastic viscosity of the drilling fluid, measured in centipoise. The plastic viscosity is calculated by measuring the shear rate and stress of the fluid using a Fann viscometer. The Fann viscometer is a rotating sleeve viscometer that comes in two models, a simple hand-operated 2-speed model, and a more complex variable speed electric model. The 2-speed model operates at 300 and 600 revolutions per minute. The viscosity of the mud is one of the principal factors contributing to the carrying capacity of the mud, the suspension of weighting materials, and pressure surges applied to the formation through frictional pressures in the annulus. That's why it's crucial to control the solids. We have solids that are an integral part of the mud and solids that are undesirable. As the mud density is increased by the addition of barite or hematite, the plastic viscosity will automatically increase. The viscometer is designed to give the viscosity of a Newtonian fluid when used at 300 revolutions per minute. For non-Newtonian fluids, the ratio of shear stress to shear rate is not constant and varies for each shear rate. With a Bingham plastic fluid, a finite force is required to initiate a constant rate of increase of shear stress with shear rate. To obtain a value for this constant rate of increase, readings are taken with a viscometer at 511 sec-1 and 1022 sec1, 300 and 600 revolutions per minute. The 600 dial reading minus the 300 dial reading gives the slope of the shear stress-shear rate curve. This is the plastic viscosity. The apparent viscosity is given by the 600 reading divided by 2. This is a measure of that part of resistance to flow caused by mechanical friction between solids in the mud, solids and liquids, and the shearing layers of the mud itself. So there you have it, guys. That's part 1 of the Drilling Fluid Report video. Be sure to check the part 2 of this topic. Don't forget to hit that subscribe button and turn on the notification bell to never miss a video. Thanks for watching, and I'll see you in the next one.